Hello friends, let me first welcome you all to our lecture series on the subject internal combustion engines and gas turbines. Today in this series we are going to discuss about the combustion in SI engines. Initially we will be discussing about the requirements of combustion in SI engines, followed by how the combustion happens theoretically and actually in SI engines. That is, we will be discussing about different stages of combustion in SI engines. So let us start. So first we will be discussing about requirements of combustion, and in order to understand requirements of combustion, first let us see what a combustion is. So basically the combustion is burning of hydrocarbon fuel in the presence of air in order to produce carbon dioxide and water, and this is happening with the liberation of heat. That is carbon from hydrocarbon fuel combines with oxygen to form carbon dioxide. Hydrogen is oxidized to H2O and liberating heat. So this particular process is what we call as combustion, and in order to happen this properly, some requirements are there. So what are the requirements of the combustion then? So first is there should be the mixture present which should be combustible. So what it means? It means that in SI engine preferably we know that the mixture is going to burn within a limit what we call as inflammability limit. If the mixture is leaner than that or richer than that, this mixture is not able to burn. That is where we call it as the presence of mixture should be there, which should be combustible, that is within the inflammability limit. Next requirement is to have some mean of initiation of combustion. That is, it is not just sufficient that the mixture is there, it should be able to be burned. So in order to ensure that it is going to burn, there should be some method of igniting it, burning it, and that is where we have what we call as a spark plug. Now this particular mixture which has started its burning and converted into flame, this flame has to be stabilized. So we need to ensure that the flame is going to start, it is going to stabilize, and the flame is going to propagate throughout the combustion chamber in a very uniform manner. So that has to be there. Then as this particular flame is going to travel, we have to ensure that all the fuel and air inside the combustion chamber, which we have introduced in the form of a mixture and some work has been done on it, is going to be utilized. So utilization of the air and fuel is also a required condition for the combustion in SI engines. Now let us discuss how this particular combustion happens theoretically inside the combustion chamber. So theoretically we know that the combustion process is instantaneous. So this particular figure indicates the pressure crank angle diagram for combustion in case of an engine. So here it is shown, this particular curve is related to pressure. So as the piston moves toward TDC, that is top dead center, we can see that the pressure is going to increase. So when the piston reaches B, that is A to B, the curve indicating the compression process. So during compression process, the pressure is going to increase, and at B we give the spark. Theoretically we ignite the mixture when the piston reaches TDC. So as we are assuming that the combustion is going to happen instantaneously, the pressure is going to rise from point B to point C, and the C corresponds to the point where the peak pressure is finally attained. So BC indicates the instantaneous combustion curve for pressure. And from there, that is, as the piston starts moving from top dead center towards BDC, then pressure starts decreasing. So CD corresponds to the curve where the pressure is going to decrease. So that is expansion stroke. So AB corresponds to compression stroke, BC corresponds to the combustion process where instantaneously it is happening, and CD corresponds to the expansion stroke when the pressure is going to decrease. So this is the theoretical process what is supposed to happen inside the combustion chamber. But in actual, we know that combustion process is not instantaneous. How it is not instantaneous? Initially we know that we give the spark not at B but some degrees before the piston reaches TDC. So spark is ignited before the piston reaches top dead center, and so finite amount of time will be utilized in order for the combustion to happen. Therefore the curve which has shown theoretical will not be the actual it will be something different. So let us see how actually the combustion is going to happen inside the combustion chamber. So we know that the mixture, homogeneous mixture is required for the combustion, and it has been supplied by the carburetor. So a carburetor is used to supply the mixture to the combustion chamber, and as the piston reaches almost nearer to the TDC, a spark is given, and this spark is going to ignite the mixture. And when the spark is given, what is happening? Due to that particular spark, the region in which the spark has been initiated, the fuel is going to burn, and a nucleus of flame is going to be, which is then supposed to be converted into a full-fledged flame. And this particular flame is supposed to travel across the combustion chamber, consuming all the mixture. This particular flame is supposed to ensure that all the fuel and the air is going to be utilized, and this is how the combustion happens. And all these things happen in different stages, and here you can see the different stages. So 1, 2, 3, so there are different stages, and this is how the combustion actually happens. So it is very important then to discuss what these particular stages are. So the 3 stages in the combustion we will be explaining one by one. So let us start with the first stage. The first stage is your ignition lag. That is, here it is starting from A to B. A, which is the point of initiation of the spark, and the B, which is the point where there is a noticeable pressure rise. This A to B curve indicates the ignition lag period. What is actually happening in this particular stage of ignition lag? We know that air fuel mixture is available, and the fuel molecules are going to be getting heated up due to the compression. So sufficiently we are able to increase the temperature. So at a certain point we are going to give a spark. So at point A we have given the spark. Now when the spark is given, a self-propagating nucleus is going to form. Region around spark, the fuel is able to burn, and this is converted into a nucleus, and this particular nucleus is going to slowly grow, and it is getting converted into a flame, and this amount of time required to happen this particular the nucleus into a full-fledged flame depends on so many things. What are these things? The physical and the chemical properties of the fuel. The physical properties, like what is the pressure, what is the temperature inside, what is the cooling available, what is the design of the combustion chamber. Then the chemical properties of the fuel, what are the constituents of the fuel, what is the self-ignition temperature of the fuel. All these things are going to decide what will be the time required for A to B, and also it will be depending on the quality of the mixture. So generally it is observed that a slightly rich mixture gives least amount of time from A to B. So if it is deviating from this slightly rich mixture towards richer side or leaner side, then the time required for completion from A to B will be more, and this is what generally happens in ignition lag period. That is the first stage of combustion in SI engine. So summarizing what happened, we have given the spark burning the mixture to form a nucleus, and the nucleus is slowly burning and getting converted into a flame, and this particular process is taking some amount of time, which we call as ignition lag. And the next stage is second stage of combustion, which we call as a flame propagation stage. Here it is denoted by points B to C. So what is this point B? Point B is the point where we have observed a noticeable rise in the pressure. In order to understand this, we should understand first what are these particular two curves over here. Here it is one motoring curve and one is a combustion curve. We know that as the piston is moving towards the top dead center, the pressure is obviously going to rise. So the pressure is rising inside the combustion chamber, and if there is no combustion and the piston is going to move down, then the pressure curve will go like this. And this correspondingly, whatever curve we are getting, what is called as motoring curve. But when the combustion is happening, the curve is going to depart over here. From A to B, we have not noticed any change in the pressure, because even though the nucleus has been generated, it is burning, it is growing, the whatever heat is liberated by one molecule is being absorbed by the surrounding molecules for heating themselves and reaching self-ignition temperature, and the net temperature of the combustion chamber is not increasing. So there was no noticeable rise in the pressure from A to B, even though the combustion was happening. But after the point B, there is a noticeable pressure rise, and that is where we say the combustion curve departs from the motoring curve. So what happens in this particular stage? The combustion curve departs from the motoring curve, and the flame is going to travel across the combustion chamber. So initially the nucleus was started at the spark plug and it is getting converted into a full-fledged flame, and the full-fledged flame is now traveling from one end of the combustion chamber where the spark plug is rotated to all corners of the combustion chamber. So this particular flame is going to travel across the combustion chamber, and it is going to ensure that almost all the fuel inside the combustion chamber is burnt. Where almost all the fuel is being burnt, the amount of heat produced will be higher, and therefore at the end of this particular stage we can assume that the pressure is almost maximum because almost all fuel has been burnt. So stage starts from the point where there is a noticeable rise in the pressure till maximum pressure is being reached, and this particular rate of pressure rise is proportional to rate of heat release. So amount of heat release, if it is more, then this curve will be steeper, but if the heat release is lesser, then the slope will be lesser and it will go like this. So that is the meaning of what the rate of pressure rise is proportional to a rate of heat release. And this particular stage is now going to end at point C where the maximum pressure is attained. So this is what is happening in what we call as a flame propagation stage or second stage of combustion in case of SI engines. Now let us see what happens in case of a third stage of combustion, which we call as afterburning. The afterburning starts at point C. So what is the point C? The point corresponding to the point C, it is a point where we are able to achieve the maximum pressure. Maximum pressure has been reached, and thereafter whatever happens is in the third stage of combustion. And what is happening during this particular stage? The unburned mixture in the dead pocket is going to burn. Now what are these dead pockets inside the combustion chamber? So you can see over here there is a combustion chamber, and in the gap between the piston and the cylinder wall there is some gap over here, and this particular gap there is some amount of mixture. Similarly at this particular corners where we have the spark plug, so in this corner there is some amount of mixture. Similarly at the walls at this particular corner there is so there are some dead pockets inside the combustion chamber where the mixture was unable to burn when actually the flame traveled in the second stage of combustion, because in this particular region the surface to volume ratio is higher, and due to the higher surface to volume ratio the heat was lost to the combustion chamber wall, and therefore the mixture was unable to reach self-ignition temperature before the flame was getting traveled in the combustion chamber, and therefore they were unable to burn. Since they were not able to attain self-ignition temperature, they were unable to burn. But once the flame has traveled, sufficient heat is available now in the combustion chamber, so they are now available with the more amount of heat, and whatever heat is now available is able to increase the temperature of this particular mixture in the dead pockets to sufficient higher temperature where they can reach self-ignition temperature and burn. But now the piston has already traveled towards BDC. From TDC, piston has already started its travel, and therefore whatever mixture is going to burn in this particular stage, that is after the piston has started travel from top dead center to bottom dead center, that is from here to here, we know that the pressure is decreasing, and since the pressure is decreasing, even though some amount of fuel is going to burn, it is not going to contribute in the power production. So in other words, fuel is going to burn in the third stage of combustion, which we call as afterburning. It is not going to contribute in the production of the power or increase in the power. In other words, whatever fuel is burning in the third stage, we can say it is going to be wasted. So this is what generally happens in the third stage of combustion. In all, we have three stages of combustion in case of SI engine. In the first stage, nucleus was generated, and that particular nucleus was converted into a full-fledged flame. This was what we call as the ignition lag. In the second stage, full-fledged flame was traveling from one corner of the combustion chamber to the other corner, consuming almost all the fuel, and therefore the pressure was able to reach its maximum. And in the third stage, some fuel here and there in the dead pockets which was remaining unburned was able to burn in the last stage whenever it is able to get sufficient amount of heat and reach self-ignition temperature and burn. So that is your third stage. So this is about the different stages of combustion in case of SI engine. Thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends, and don't forget to subscribe to our channel. After subscription, you can press the bell icon to never miss the notification regarding our new video.